A worker ant is carrying food back to the nest, on the same path, at the same pace, like it has done it 10,000 times before. Then it stops. It drops the food, turns away from the nest, and walks in the opposite direction, away from its colony, away from everything it has ever known.
And that's what's happening here. They're actually, give their lives to prevent the rest of the colony from drowning.
Hours later, it falls, and its head separates cleanly from its body. No struggle, no wound anyone can find. Just gone. By the end of this video, you'll know exactly what did this, why every obvious explanation for it turns out to be wrong, and why the real answer isn't one killer at all. It's a coordinated team of them, 6 different specialists, each one built to hunt a different kind of victim, and almost nobody outside a handful of research labs knows they exist. Stay to the end, because the reason Israel is looking at this program right now is not what you'd expect either. To understand why this matters, you need to know what these ants actually are. Solenopsis invicta, red imported fire ants. Originally from South America, spread across the globe through international trade, and were first discovered in Israel at the end of 2005 in the Jordan Valley. Their sting is nothing like a normal ant bite. It burns for hours, sometimes days. They never attack alone. They swarm, and they keep stinging the same spot over and over. Small animals often die from it. People with allergies can die from it too. In the local ecosystem, they are the thing everything else learns to fear, and an entire colony of them had just been wiped out. The die-off didn't happen all at once. It followed a pattern, and the pattern is what made it disturbing. First, the food deliveries stopped, not gradually. Within minutes, worker ants simply quit bringing supplies back to the nest, like they'd forgotten their own job existed. Then, construction halted. Outside activity dropped. Large worker ants started disappearing one at a time. Some of the remaining ants began behaving strangely, slower, disoriented, moving like something wearing an ant as a disguise. And then those specific ants walked away from the nest and never came back. So, who did this? Investigators worked through the obvious answers, and each one collapsed the moment it met the evidence. Local predators. First, this is dry, sandy terrain, and it has no shortage of hunters. Scorpions sit at the bottom of pits and wait for prey to fall in, so they don't breach a colony from within, and they'd have caught the occasional straying worker at best, not hundreds. Geckos swallow prey whole, so the ants would have simply vanished one by one, not been left behind as separated heads. Spiders leave webs and drained hollow husks, and there was no web anywhere near the site, and what remained didn't look drained. It looked deliberately taken apart. Poison, next. Poison kills fast, and it kills everyone roughly the same way, clumped together near the nest entrance, legs curled, in a matter of hours. This colony died slowly, over days, in a specific and repeating order, and the dead weren't clumped at all. They were scattered, alone, far from home. War with a rival colony? Ant wars leave torn limbs, stolen larvae, chaos at the entrance, bodies missing legs and antennae as much as heads. Here, there was no chaos, no sign of a battle line, no stolen brood, just heads, cleanly separated, and nothing else. Disease, the most reasonable guess of all? Ants live packed together and share tunnels constantly, which is exactly how an outbreak should spread. But disease doesn't make an ant walk calmly away from everyone it knows before it dies, and no known ant virus severs a head clean from a body. Every external explanation had the same problem. Something had gotten inside these ants, and it had gotten inside long before any of them showed a symptom. There was one detail investigators almost missed. Every so often, a fly would appear over the colony, ordinary-looking, small enough to overlook, and the ants reacted to it like it was the size of a helicopter. The moment it got close, everything stopped. Ants abandoned their trails. Some flipped onto their backs, jaws open, trying to fight something their jaws could never actually catch, because the fly was simply too fast. It would dive, brush a single ant for less than a second, and vanish. That ant would stand up, dust itself off, and go right back to work. Nothing seemed to happen. A few days later, that exact ant started slowing down, getting disoriented, and then it walked away from the nest and never came back. The fly wasn't just startling the colony, it was hunting one specific ant at a time, using the aggression pheromone fire ants release under stress to find its target. In less than a second of contact, It used a needle-thin ovipositor to inject a single egg into the ant's neck. No visible wound, no pain sharp enough to register as a threat. The ant walked away carrying its own executioner and had no way of knowing it. The egg hatches within days. The larva does nothing dramatic at first. It just waits and slowly migrates toward the ant's head. That's when the behavior changes begin, subtle at first, because something is now learning to operate a body it doesn't fully control yet. Eventually, the larva reaches the head cavity and starts consuming brain tissue from the inside. And as it does, it doesn't just weaken the ant. It steers it one direction, away from the colony, far enough that nothing can find and stop what happens next. Only then does the ant die. As enzymes dissolve the tissue holding the head in place, the head comes away clean. And it isn't a corpse at that point. It's a nursery. The larva keeps developing inside that severed head for another 2 to 4 weeks before an adult fly finally climbs out and goes looking for the next target. That fly did not arrive at this colony by accident. Researchers released it there on purpose as a weapon. This is where the story most people have already heard stops. And this is the part almost nobody covers, because almost nobody looks past the first fly they find. It isn't one species doing this. There are 22 known Pseudactyon fly species in South America that specialize in decapitating fire ants, and the United States didn't pick just one and call it done. Over roughly a decade of testing, researchers screened them individually against native wildlife, against pollinators, against every risk they could think of, and deliberately established 6 separate species across the infested South. Pseudactyon tricuspis, P. curvatus, P. littoralis, P. obtusus, P. nocens, P. cultillatus. Each one isn't a redundant copy of the last. Each one targets a different slice of the same colony. Some are built to attack the largest worker ants, the soldiers a colony can least afford to lose. Others specifically go after the smaller foragers the bigger flies pass right over, the ones doing the actual day-to-day work of feeding the nest. Their active hours don't fully overlap either, so a colony that adjusts its foraging schedule to dodge one species can walk straight into another. It isn't a single assassin picking off targets at random. It's a division of specialists working overlapping shifts, engineered piece by piece, species by species, to close off every escape route a fire ant colony has left. This is not something that happened by accident either. It traces back to the 1930s, to a cargo ship that docked in Mobile, Alabama, carrying fire ants in its ballast soil. Nobody checked. The ants found a country with ideal weather, endless food, and almost no natural enemies, since the flies that kept them in check back home had never made the trip. They spread across the South, cost billions of dollars in damage every year, and shrugged off every chemical thrown at them because poison only kills what's there today, and a colony can rebuild in months. So in 1997, USDA researcher Sanford Porter, working alongside entomologists at Auburn, LSU, and the University of Texas, started doing what nobody had tried before, reintroducing the fire ant's actual natural enemies on purpose. A small lab in Gainesville, Florida, began breeding the first species by the thousand. It doesn't look like a typical lab. It looks like an assembly line built for insects. Ant colonies are kept in trays under cups that rise and fall on a timed cycle, forcing the ants to keep hauling their brood from one shelter to the next, never allowed to settle. That constant disruption keeps them stressed and exposed, which is exactly the state that draws the flies in to attack and lay their eggs efficiently. Every few days, that batch of ants gets swapped out for a fresh one, and the cycle starts again, uninterrupted. It runs today as a continuous production line. What began as 1,500 flies a day scaled into tens of thousands, 6 different species deep, spreading across Florida, Texas, Mississippi, Louisiana, and Georgia, largely on their own once released. Has it worked? Not the way a poison would. Fire ant numbers in fly-established areas have dropped by only around 10 to 15%, which sounds unimpressive until you understand what that number actually represents. It isn't really about how many ants die. It's about what the ants do differently once an enemy that can reach inside their own bodies is always somewhere overhead. Colonies under fly pressure forage less, expand less, spend far more energy on defense than on conquest, and in the space that opens up, native ant species that had been pushed out for decades slowly start coming back. Which brings us back to Israel, and to the reason any of this matters there at all. Israel isn't starting from nothing. It already runs one of the most advanced insect breeding and aerial release programs anywhere in the world, built for the Mediterranean fruit fly, one of the most damaging pests to fruit crops on the planet. Israel breeds millions of sterile males every week and releases them by air over farmland, so they mate with wild females and produce no offspring at all, quietly erasing the next generation before it's born. It's a program so refined it's been exported to Italy, to Croatia, studied as far away as India, where it's driven fruit fly populations in entire mango-growing regions down to almost nothing. The infrastructure to breed, cool, transport, and release millions of insects at scale already exists, tested and proven. What Israel hasn't done yet is turn any of that machinery toward this specific enemy, this specific squad of 6. If it does, the honest answer is that it still won't erase the fire ant problem completely. It never has, anywhere it's been tried. But it would mean something has finally arrived that can reach inside a fire ant colony that nothing in the region ever could reach before. Not from the outside, from within. Which leaves one question worth asking. For nearly a century, humans tried to beat this species with poison, with fire, with every blunt tool available, and the ants adapted to all of it. It took 6 separate species of a fly smaller than a grain of rice, each one built for a different weakness, working in shifts nobody coordinated by hand to actually make a dent. What does it say that the most effective weapon against one of the world's most dangerous invasive species was never a bigger weapon at all, just a more precise one?